Hello and welcome to my presentation on Maths, Exploring Mastery and Depth. My name is Michelle Woodhams and I'm the Head of School at the Linden Academy in Luton. I've been a primary school teacher since 2007 and became Maths lead in 2010. In 2012 I successfully completed my MAST, my Maths Specialist Teacher Programme, based at the University of Herts. The key aims of this session are displayed on screen. Throughout the presentation I will share with you some activities which I'd like you to take part in. This will help you to gain the idea and understanding of what it is like to be a child partaking in these activities. First activity I'd like you to take part in is called Visualising the 100 Square. This activity you can carry out with children of any age and of any ability. Some children may need to have a 100 square right in front of them. This is so that they can point to the number and move their finger along the grid as you describe different things. Some children may just need to be able to glance at one that is up on display and refer to it as and when they need to. Others will just be able to close their eyes and visualise it. This will depend though on how much exposure they have had to a 100 square. Therefore, don't presume that all your greater depth and your older children will be able to just visualise the 100 square. It's all down to experience. For this, they will also need to know either compass directions or other positional language. For you, I'm going to use the compass directions. So if you can now visualise the 100 square in your head and place your finger mentally on number 55. Have you got it? I'd now like you to move that 3 places north. So 55 moving 3 places north. What number did you land on? That's it, 25. Perfect. You're now at 25. I'd like you to move 3 places south and 2 places east. So from 25, 3 south and 2 east. What number are you on? 57, I hear you cry. That's correct. Finally, staying on 57, I'd like you to follow the next instructions. So 57, I'd like you to go 4 south, 2 west and 2 north. That's 4 south, 2 west and 2 north. What number have you ended up on? 75. This is a great warm-up activity to get children used to using the 100 square, and it can be adapted so you could change it from 300 to 400 say, or in the thousands, or even decimals, as children should be familiar with the layout and should also be able to describe the patterns that they can see. For instance, when they go up and down, they're changing the tens but not the ones digit, and when they go left and right, they're changing the ones but not the tens digit. This allows for great discussion and talk within your classroom. So what is mastery in maths? These sentences are taken from the NCETM website, the National Centre for Excellence in the Teaching of Mathematics. This is a great website if you haven't yet explored it, as it is rich with activities and resources that you can use. So mastery is all about getting children to have a deep, long-term, secure and adaptable understanding of maths. It's about making sure their understanding is solid enough that when it gets to more advanced materials, they can move through it more easily. I feel very passionately about including this slide in this presentation. Who is mastery for? All children should have the opportunity to master maths. This is regardless of their ability and age. I feel it's a common misconception with many teachers and adults in school who feel that only the most able can master maths. If the learning is pitched correctly, all children can master. Richard Skemp looked at how children understand rather than just know maths, and he said there's 2 types of teaching and learning. One is instrumental, so you teach by rote, or you teach just so that they can do it. It just requires the children to remember. This may be how you remember learning when you were younger. I know that I spent many a time just learning how to do something over and over again until I got it. When my friends questioned my GCSE teacher as to why we were doing certain things, she'd become very flustered and just tell us because we had to. The other type of teaching and learning is relational, where we teach children to form relationships between what they know, so that they are able to apply their learning. This is what mastery is all about. Here are 3 key questions that can be used in everyday lessons. What do you notice? What is the same? And what is different? I learnt these on my MAST course, and they became a feature of every lesson that I held with the children, and they soon became used to being able to answer these questions naturally without me posing them. The other thing I brought in following my MAST was the question, can you prove it? Children could complete 5 or 6 calculations. They'd come to me and then I'd say, go and prove it. They'd have to think about how they could show it in different ways. This is mastery. These are the 5 big ideas to teaching for mastery. And this diagram is taken from the NCETM website. So teaching for mastery involves 5 ideas: coherence, representation and structure, mathematical thinking, fluency and variation. These don't have to happen in a particular order. They can follow on from one another. They actually all can merge together, as you'll see throughout this presentation that many aspects of the big ideas all flow into one another and overtake each other. So the first big idea I would like to explore with you is coherence. This is when lessons are broken down into small connective steps and they allow children to access the learning and then be able to lead to a generalisation of the concept so that they can apply it to other areas. Mason in 2005 said a lesson without the opportunity to generalise is not a mathematics lesson. Here is an activity that will just show you how we move from specialising to generalising. So on the board I have a specific number of 34. And I'd just like you to take a few seconds to fill in the missing squares. Here's your answer. Did you get them? So like I said, this is specialising. You've got a specific number. It could be 24, it could be 88. It doesn't matter. You just fill in those squares based on what's around it. But now let's look to generalise. Instead of giving a number, we're going to just call it n. To make a generalisation, we'll say the square above is always n minus 10. We know that's true on a 100 square. The square to the right is always n plus 1. The square directly below is always n plus 10. And then the final square is always going to be n plus 9 or n plus 10 minus 1. It doesn't matter now what number goes into the middle. This generalisation will work. It could even be a decimal, 3.4. It could be thousands, 3,443. It doesn't matter, you've got the generalisation and now you can work with it. You could also change this activity by just adding in some additional boxes. This could make it more complicated for certain children, or you could take some away to make it less challenging for others. Another activity that leads children to make generalisations is always, sometimes, never. Here I have 3 statements and you might want to just pause for a moment so that you can have a go at proving these statements. Proving it means representing it, means showing it. I'd always tell my children that they had to show at least 5 examples to prove to me if it was always, sometimes or never. Here are your answers. When you multiply an odd number by an odd number, you get an odd number. This is always true. When you add 2 numbers, you get the same result as when you multiply them. This is sometimes true, as adding 2 numbers that are the same is the same as multiplying 2. The children may not have used adding 2 numbers that are the same, and therefore they might not come up with the right answer. So you will need to probe further with them and look at them working in a logical and methodical way. Statement 3, multiples of even numbers are even numbers. That is always true. This is just another aspect of always, sometimes, never to show you that it can also work with different areas of maths. So here we have shape and some different statements that the children can work on to prove if it's always, sometimes or never. The next big idea is mathematical thinking. This is where children should be able to use and apply their knowledge. It should be the core of teaching and learning. The Department of Education, alongside Oxford University, say mathematical reasoning, even more so than children's knowledge of arithmetic, is important for children's later achievement in maths. So if children are taught to understand more deeply, to be active in their learning rather than just taking it all in, they should be able to think about it, be able to reason, and be able to have thoughtful discussions with others in their class. Mathematical thinking is when you are delving deeper, thinking about how you know, explaining, reasoning, justifying, applying a range of skills, putting into other contexts, forming relationships, seeing patterns, and forming connections whilst being logical. Bowler in 2009 said, "Students who learn to reason about situations learn that mathematics is a subject that can make sense of rather than being a list of procedures to memorise." For me, every lesson should involve reasoning. The next few slides that I share with you are ideas that you could use in your classroom to develop mathematical thinking. They can easily be adapted to suit the topic you are studying. Stop and pause the video as you go along and have a go yourself. Here we have target number. This can be used with all 4 operations, but for here I have used it for multiplication. I've chosen to use a 5x5 grid, but you can adapt this to be as small or as large as you like. And I've made a target number by picking 2 numbers from the board. The instructions for the children, or for yourselves if you'd like to have a go now, is to pick 2 numbers from the grid, a tens and ones and a tens and ones. Multiply the 2 numbers together and see if you can find the 2 numbers that make exactly 575, or how close can you get. This is all about mathematical thinking, so you want the children to be able to record their ideas as they go, whether that's by writing them or verbalising them to you so you can make notes as you hear them justify their choices. So for example, this child might say, "I first of all chose 50, excuse my handwriting on here, times 10, because I know that I'm going to get 500. So I felt like this was a good starting point to get as close to 575 as possible. However, that's too far away. So then I chose to move to 50 times 11, knowing that I'd get 50 more. That's 550. I'm 25 off." So you get the idea that they're justifying and thinking. This shows you how much children know about the relationship between number and by multiplying. They're mastering all the time. If a child were to choose, say, 99 and 74, you might start to think about their understanding of the size of number and the impact of what multiplication is going to have. A simple task that gives away a lot of deeper understanding. Here we have a 3x2 grid, so 6 spaces, and the children are going to need 2 red counters, 2 blue counters and 2 green counters. There's then a set of instructions that the children need to follow in order to place their counters correctly on the grid. Once they've found one way, you could ask them to explore if there's other ways. Children might not want to use concrete resources, or you might not want them to. You might want to challenge them further. They can then draw instead. Concrete, pictorial, abstract, moving from holding on and manipulating to drawing and representing. Again, the children can process their thinking and explain their understanding to you. So there are no blue counters in the middle column. So therefore, this child might decide they're going to place their 2 blue counters here. There's a lot here about language as well. If they don't understand what column is, they might go wrong, what row is, and also what adjacent is. So there's lots of mastering and being able to apply other aspects of their learning. Another task here is completing the grid so that you can fulfill the rules at the bottom. A number has already been placed, so fill the square of the following numbers to make 3 3-digit numbers. The 3-digit number in the second row is twice the number in the first row, so I'm just going to put an aide-memoire there. The 3-digit number in the bottom row is 3 times the number in the first row. So children will start to play around with the numbers that they have. Say, for example, they put in here an 8. You might want to stop and challenge their thinking. If they're going to do this is 3 times the 8, they're going to have to use the number 24, but there is no 24 in their list. So again, this will give you a good idea of their understanding of the relationship between number, what multiplication actually means, and whether they understand some of the vocabulary within the rules. You can change these rules to change the aspect of the grid. Another activity to allow the children to develop their mastery is true or false. Here you can just display a few different statements on the board. The children can pick and choose through them, and they can prove to you through showing some different examples or a range of number of examples whether or not the statement is true or false. They need to prove it to you, so different representations can also be used. One of my particular favourites is a concept cartoon, as they're great at getting the children to spot mistakes, explain what's gone wrong, and look at other ways of doing things. This one is one I've made myself. I used to love making my own concept cartoons, but you can purchase them. Children can also make their own concept cartoons if you give them a blank template. This really allows you to see if they fully understand what they're doing, because what they put in their bubbles and their examples really shows you how deep their knowledge and understanding really goes. Here I've chosen to put the problem around multiplication of 3-digit by a 2-digit. And we're using the grid method in the classroom, so they've all got the same examples. However, you might want to change this and have different ways of presenting or finding the answer, so the children can look at that as well. The children will mark this and they can provide feedback to each of the children to say what's gone wrong and how they can improve next time. The next big idea is representation and structure. Representations used in lessons expose a mathematical structure being taught. How we represent an idea in mathematics is a key part of the process by which we develop understanding and give meaning to that idea. Barnby et al. 2009. Children need you to model as many different representations as possible so they can build up their own internal bank that they can rely on. For example, I only remember being taught column addition when I was younger. I don't remember any other process up to it. So when I visualise, before I started teaching, to add up in my head, I would visualise the column addition method in my head and work through it. Children also need to use resources. It doesn't matter what age or ability, they should always have the opportunity to get hands-on. They need to also know how to use those resources and what things might look like on different equipment. For example, they might need to see the number 52 as numicon, on bead strings, on the number line, on the number square, with counters, etc. This all helps them to build up that internal bank of representation that they can draw on when they need to. Just stop and pause for a second and think of the different ways you represent maths in your classroom. Or do you rely on that way that you do it? Do children's representations get celebrated enough and shared enough? So a question for you. What's this? What am I thinking in my head when I display this to you? Did anyone say 2 rectangles side by side? Did anyone say it's representing symmetry? It's equals on its side. Parallel lines. The number 11. 10 plus 1. 10 plus a unit, or in new money. A 2-digit number. Or it's 11 o'clock, or 5 to, or 55 past, or 23 hours if we're working with 24-hour clock. I bet many of you presumed it was to start with was the number 11, but this actually represents all of these things. No single one of these is right. Representation can be shown in different ways. We can use words, images, symbols, and also actions on objects. For example, the number 3 could be blowing out 3 candles, putting 3 sweets in the bag. When we represent, we want to move between CPA, concrete, pictorial, and abstract. This diagram here allows the children to do that because they can use the objects, the concrete, they can draw the symbols and the images, and then they can work with the abstract, which is normally more of the words and the actual doing. This bit here can be absolutely anything you want it to be to get the children to represent different things in maths. Here's another activity that you could use in the classroom that requires representation in different ways, depending on where the child is at. So the problem is the frogs want to swap sides. Frogs can only jump to empty lily pads. Frogs can only jump over one other frog at a time. Frogs don't know how to jump backwards. How many jumps does it take? So children might need to use concrete objects. They might need to be able to manipulate and move things around before they can do this. Others might be able to represent this by drawing it and showing the different steps that it takes. Some might move on and be able to use letters or symbols that represent the frogs and show the process. There are many different activities that involve problem solving where representation is needed. Another big idea is fluency. Fluency features heavily in the national curriculum that was introduced in 2014. You may have heard of things like Fluent in 5, which gets the children to focus in on something they've already been taught, something they're currently being taught, and something they're going to be taught in the future. But fluency is all about having that quick and efficient recall of facts and procedures so that children can easily move between different contexts and representations of maths. They need to be able to do things efficiently. Dalker in 1992 said, "To the person without number sense, arithmetic is a bewildering territory in which any deviation from the known path may rapidly lead to being totally lost." So let's have a go at an activity to do with fluency. I'm going to flash up an amount of objects for up to 3 seconds. Write down the amount that you see. Here goes. So the answers are 5 ducks, 7 cars, and 8 minions. Was there one representation that was the easiest to identify? Was there one that was the hardest? You might just want to stop and talk about it. For me, the 5 was the easiest one to identify due to the layout I gave, which reminded me of a dice. I also found 7 quite easy due to the arrangement of the cars. The minions was the hardest for me as there was no real pattern for me to spot or anything I could link the arrangement to. Perhaps if I'd seen it in an array, 2 lots of 4, that might have just helped me get to that answer quicker. So the different ways we represent things has an impact on the children. So the purpose of that activity was to show you something called subitizing, which is the ability to instantly see how many objects there are without having to count them. Children need to rely on pattern recognition to be able to discover these essential properties of numbers. This is an important skill that children need to possess, and there are 2 others that we're about to explore. These are number magnitude and developing fact piles and inventing strategies. So number magnitude is the ability to comprehend, estimate, compare and order number size. Developing fact piles and inventing strategies is about children recognising the relationships between things in order to create their own basic number fact piles, such as decomposing 5 into 3 and 2, or 10 into 3, 3, 3 and 1. Children need to learn how to manipulate and adapt through their own invented strategies, which will help them lead to fluency. So a task for you. Can you think of the different ways in which you could solve 14 plus 26? Be like a child, go as extreme as you like. Russell in 2007 looked further into fluency and suggested that it consists of 3 elements. 1. Efficiency, 2. Accuracy, and 3. Flexibility. So fluency is much more than a child being able to memorise a procedure. They need to understand why they're doing it, what they're doing, and know when it's appropriate to use different methods. Going back to that 14 plus 26, which methods did you use? Before looking at mastery and before exploring this as a teacher, I would have pictured that column addition in my head and worked through that from the 1s to the 10s. However, now I look at it in a different way. I look at my 6 and my 4 and I know that they make a number bond of 10. I then look at my 10s. I know that 10 and 20 or 1 and 2 is 3, so that must be in 30. And then I combine it and I know I've got 40. That's now the process I work in my head, which is much more efficient than picturing a column addition and working my way through it. It's really important that you celebrate different methods in your classroom. Have a strategy section on your working wall and record the different ways in which children come up with their ideas. Look at these calculations and then look at the strategies. Which strategy is the best for the different calculations? Do your children know all of these ones? Share this with your class if you feel it's appropriate and see what they would tell you and listen to their reasons why. This is all mastery. They're able to explain, represent, and be fluent in what they're doing. Just pause and reflect on your own practice. Do you allow them to partition numbers in a variety of ways so they're not always looking at 10 as 5 at 5, but all the different combinations that they can possibly get to? Do you let them invent their own strategies? Do you celebrate them? And do you work with the children on being more efficient, or do you just let them know that one strategy and then move on? The final big idea to share with you is variation. Variation does require time and thought. When you're planning and thinking of your questions, you need to think about the variation you're going to use. It's so important as it does impact how the child will learn. We perhaps sometimes as teachers don't recognise that the questions we choose to ask the children, the order in which we do them, has such huge impact on the progress that they make and the deeper understanding that they get. Variation is not the same as variety, and we need to be careful with that we don't just think it's given a range of different questions or sums that the children need to answer. So this slide, taken from the NCETM website, shows you the difference between variety and variation. Here on the left-hand side, we've just got a pick and mix of questions looking at subtraction, because that might be what we've been studying in class, but there's no real direction or purpose to the questions that are being asked. The children won't be able to spot and notice key connections. However, on the right-hand side, carefully planned and designed questions allow the children to start to make connections between what they're doing. They're designed so that this draws attention to a key concept. The choices you make for your questions is called procedural variation. This slide here, again taken from the NCETM website, explains the rationale behind the choices of the questions picked by the teacher to give to her class. It will allow them to explore a key structure and be able to discuss their ideas mathematically about what is going on. These are some further useful links to help you look further into variation of procedure and concept as well. To end my presentation, I'd like us just to go back to the aims shared at the start of the session. I hope now that you feel that you have a greater understanding of what teaching mastery and depth in maths means, that you know and understand the 5 big ideas that underpin mastery, and that you've gained some ideas of how you can develop mastery in your own classrooms. Thank you very much.